we're going to evaluate the integral of the square root of x squared minus 9 divided by x cubed. And we'll be using the technique called trigonometric substitution to solve this problem. Now the radical in our integral matches the radical that looks like this, square root of x squared minus a squared. And a squared then is 9, so a is going to be 3. The standard substitution whenever we have a radical like this and use trig substitution is to let x be a times secant theta. In our case, the substitution will be x equal to 3 times secant of theta. Differentiating, dx becomes 3 times secant theta times the tangent theta d theta. Then replicating what's inside the radical, we need to square the x. That gives us 9 secant squared theta. And then take x squared and subtract 9. So this is 9 secant squared theta minus 9. Factoring out 9 times quantity secant squared theta minus 1. By trig identity, that's 9 times tangent squared of theta. And that's what will allow us to get rid of the radical. And let's go ahead and plug this in. Our integral becomes the integral. In the numerator, we have square root of 9 tangent squared theta. In the denominator, we have x cubed. Remember, x is 3 secant theta, so that's 3 cubed, 27 secant cubed theta. And then we have dx, which is 3 secant theta tangent theta d theta. Now we need to simplify. We're going to assume the square root of tangent squared is tangent. Square root of 9 is 3, so we have 3 tangent theta times 3 secant theta tangent theta divided by 27 secant cubed theta and then d theta. So note that we have in the numerator 3 times 3, which is 9. In the denominator we have 27. That cancels and we end up with 1/3 times one of the secants will cancel, so we have tangent squared theta in the numerator that's left, and in the denominator we have secant squared. So this is what we have to evaluate. The best way to evaluate this is to change tangent and secant to sine and cosine. So tangent squared is going to be sine squared theta over cosine squared theta. And the denominator is secant squared, so that's 1 over cosine squared theta d theta. Notice that both cosine squared here and here will cancel, and therefore our integral now, the remaining integral, is sine squared of theta. Now this was done earlier in an earlier video. If you don't recall how to do it, I'll go ahead and solve this, but you should memorize this kind of integral in the future. The trig substitution that we need is sine squared theta equals 1/2 times 1 minus cosine of 2 theta d theta. So this is now 1/6 integral 1 minus cosine of 2 theta. This is easily integrable, so there are no problems here. We end up with 1 over 6 times theta, and the integral of cosine of 2 theta is 1/2 sine 2 theta. Multiplying by 1/6, we have 1/6 theta minus 1 over 12 sine of 2 theta. We'll use another trig identity to simplify this, because remember our final answer must be in variable x, so this is 1/6 theta minus 1 over 12, and sine of 2 theta is 2 sine theta cosine theta. So we have 1/6 theta minus 1/6 sine theta cosine theta. All we have to do now is express these as functions of x. Remember our original substitution was x equal to 3 secant theta. So solving this for secant theta is x divided by 3. Here's my right triangle. And this is the right angle. We'll call this angle theta. Secant is hypotenuse over the adjacent. The opposite side is If you can always go back to the integral and look at the radical in the integral, that's what the missing side will always be, or you can just use Pythagorean theorem. So our opposite side is square root of x squared minus 9. Now we come back to our original problem. One more thing, we want to solve for theta. Theta is equal to inverse secant of x over 3. So that's again easy enough. Let's go back to our original integral. It was the square root of x squared minus 9 over x cubed, and then using the substitution x equal to 3 secant theta, we came up with the solution 1 over 6 theta minus 1 over 6 sine theta cosine theta. All we have to do again is just to express this as a function of x. So the final answer is 1 over 6. Theta is inverse secant of x over 3 minus 1 over 6 sine theta. From the triangle, sine is opposite over the hypotenuse. So this is the square root of x squared minus 9 divided by x. And cosine is the adjacent over hypotenuse. This is times 3 over x. We can simplify this just a little bit. The answer is 1/6 times inverse secant of x over 3. 3 divided by 6 leaves a 2 in the denominator, minus the square root x squared minus 9. And in the denominator we have 2 times x squared. We can now add a constant of integration. For more videos, visit www.mathprepvideos.com.